Hello, my name is Pablo Montes. I'm a telecommunication engineer specialized in cloud architectures, working for Telefonica in Spain.
Hello, my name is Antonio Lopez. I'm a telecommunication engineer working for Telefónica in Spain in cloud-related matters, and also I've been involved in developing machines based on different devices. We want to present you our project Anaire. The problem we would like to help in fixing is to find a right balance between CO2 concentration in closed space and ventilation. Right now, it seems that CO2 is an indirect measure of the risk of COVID, because if there is someone who is infected, it will be much more possible that it's affecting other people and infecting other people when the air is not being renewed in a closed space. So right now, a lot of the different protocols in closed spaces in Spain just relate to open windows, open doors, and try to provide the maximum ventilation. But at the same time, that's a waste of resources probably, because it can be open and ventilate much more than is really needed. So we would like to help in finding a right balance between ventilation and CO2 concentration based on open technologies today available.
So basically, the idea is to have a device in every room in the company or the school to monitor, so we can get constant measures about the concentration of CO2, the temperature, and the humidity that we have in every room. So all this data is sent to a cloud environment, to an open data pool, and from that open data pool, it can be used for research in COVID, but also our application is going to generate dashboards and alarms, so we can notify the devices, and we can show the devices the evolution in real time that we have in each one of these rooms in the schools.
The devices we are developing are also able to locally provide alarms and indications about what is if there is a risk in the current situation. So they will be continuously monitoring CO2, temperature, and humidity through different sensors, and will invoke an alarm, audible and also a visible alarm, when the CO2 concentration surpasses the predefined thresholds that can be configured for adapting to different situations. There is also one button to press to stop the sound in case it's desired, so they can continue working or giving classes, but with the ventilation in place. The device is based on a control board based on open hardware that is continuously connected to internet through a Wi-Fi network. So the requirements for this device to work are basically to provide Wi-Fi connectivity and a correct power supply. This is a prototype of the device based on a breadboard. The idea for this prototype is that anyone without deep knowledge of technology or anything, just with the correct instructions, will be able to pinch on the different components, like the control board, the button, the sensors, the CO2 sensor, especially the lights about providing alarms of the buzzer, and the power supply, without any soldering point or any complicate manipulation. The idea will be to get fundings to industrialize these sensors so we can provide it in big numbers to different public institutions.
So basically, Antonio, if we have right now an device connected that we will go through the demo. If you want to go to it, Antonio, so we can increase the levels.
Okay, so this is a currently a working device with this is the CO2 sensor that is connected to our demo. So while Pablo is showing you the demo application in the cloud, I'm going to be blowing over here so the CO2 levels are getting increased.
Okay, so basically, this is how it looks. The demo I'm gonna just get in. We have a dashboard where we can see all the different rooms and we have the details of them. So I'm gonna open the web page, go to the demo. Okay, and this sensor right here is the one that Antonio has in his room. These other ones are devices that are being emulated by software. So what we should see here, I'm gonna increase the frequency. What we should see here is how this line increases till it reaches the 500 threshold that we set. It's a really low threshold, but the idea is to get it easily triggered. Okay, and once it triggers, we should hear that. We should hear that alarm.
You can hear now the sound,
Yeah,
and also you can show it maybe on the application. Before, well, yeah, it's growing up there. So I'm gonna press the button so it can stop the buzzer, but the light will be still on, showing that the device is in an alarm condition.
yeah. And since we have gone through from this threshold, as long as it keeps like this for 1 minute, we will see in this other window that is a Telegram window. We will receive here a notification. So we can proceed with the last slide, and as soon as we get this alarm, we will get back. Okay.
Okay, so this is the idea about the numbers that we think can fit into the funding that we are requesting. So the idea would be to cover institutions like public schools or other organizations with at least 50 devices. 50 devices is a number to cover most of medium, even big size organizations in Spain, like schools. Every device or each device, it will cost less than $100, and the costs in the cloud will be under $1,000 for 1 year. So the idea will be that with $7,000 we will be able to cover an institution for at least a couple of years. So with a budget of around $150 we will be able to cover more than 20 institutions, mainly public schools, because we think that's one of the places where this technology can help more to provide COVID safe environments, or at least a little bit safer, and also provide interesting insights about the protocols that can be followed.
Well, we just received these alerts in the Telegram channel. With this, it will conclude the demo. We would like to appreciate your time, and we hope that you want to collaborate with this project. Thank you very much.
Thank you.